Hi guys, welcome to the Pepcoding. In this video, we are going to solve meeting room 2. So in the previous question, we have done meeting room 1, in which we have to return true or false for a condition when we have given n number of meetings, and we need to tell that if a man if a man can take all the meetings or not. So in that question, we just have to return true or false. But in this question, we have given the same n meetings having starting and the ending point, that is starting time and the ending time of all the meetings, and we need to figure out how many minimum number of room how many minimum number of rooms are required to schedule all the meetings. So let's take this example to understand it more clear. Now here, this is the sample input where this 5 is, it shows there are 5 meetings, and these are the meetings having start time, ending time. The start time, first meeting is 1:3, this is m1, and m2 is 8:10, m3 is 7:08, m4 is 9:15, and m5 is 2:06. So these are the meetings. We need to tell the minimum number of rooms are required for completing all the meetings. So let's see uh, here. So here we have given the meetings start time and the ending time. But if we see these all the meetings we have given in a format which are not in an order. Here we can see there is a meeting start from 1, then the next meeting start from 8, then the next meeting start from 7, then next meeting is start from 9, and the last meeting start from 2. So first of all we need to make this input as in a structure that we can understand which meeting is starting first, and which meeting is starting after that, just after that. So let's see. So for that we need to sort this array, this input, according to the start time. So this will be like start, end, and here first meeting is 1:3, second meeting is 2:06, third meeting is 7:08, fourth meeting is start from 8 to 10, and the fifth meeting is from 9 to 15. So here now we have the structure of the meetings. So by using this structure, here it is easy to check, if we visualize uh, according to this input, how many minimum number of rooms are required. Let's see we are starting from this. We have this input after sorting all the elements according to the starting time. Now we are at the first meet. So we are at the first meet, we have no rooms. We need to assign a room for this. So here we will assign a room. Let's say it is room 1. We will assign a room to this 1 to 3. 1 to 3. Now the second meeting start from 2 to 6. The second meeting is from 2 to 6. So here we need to check, is it possible to is it possible for this meeting can be done in room 1, which already have assigned to 1 and 1 to 3, the meet from 1 to 3. So here we can see our meeting is going from 1 to 3, but the next meeting start from 2. The ending time of the first meet is 3, and the next meeting start from 2. This means we need to make a room for this, for 2 to 6. So here I am going to make another room another room, let's say room 2, for this 2 to 6, for 2 to 6 meet. Now this room is 4-1, this room is 4-2, uh, this meet is 4-1, this meet is for second room. Now the next meet is 7 to 8. The next meet is 7 to 8. Now it have choice. It have choice, either it can be done in existing rooms of these one of them, or it it should have to make another room, that is room 3, for this meet. So here if we see, we have two meetings. One is ending at 3, another one is ending at 6, and our new meet is start from 7. This means our new meet, that is 7 to 8, can can uh, can schedule the meet in room 1 or either room 3. So the order of the meet in the room is not required in this question. We just need to return the minimum number of rooms are required. So this means we can either put 7 to 8 in room 1 or room 2. So let's say this time I'm going to put this in room 2. So this 7 to 8 is going in 7 to 8 in room 2. Now the next meet is 8 to 10. Now again this have choices, either it can be done in room 1 or room 2, that is existing rooms, or either it should have to make another room for it. So here if we see, one meet is end at 3, another one in room 2 is end at 8. So either of 3 and 8, the room 1 or room 2, it can be scheduled in any room, any of these two. So order is not mattered in this again. Now this time I'm going to put it in room 1. So let's put it in room 1. So this is scheduled in room 1 from 8 to 10. This is for room 1. Now next meet is from 9 to 15. Again it has choice, either it can make a new room or it can be scheduled in existing one room. So again we will check for both rooms. Here one room is end at 10, the meeting is ending at 10, another one is ending at 8. So here this time this meet is start from 8, and in room 1 the meet is going till 10. So this means this 9 to 15 cannot be scheduled in room 1. So it will check for the room 2. Here room 2 is ending at 8 and it is starting from 9. So this means it can be scheduled in room 2. So this will be scheduled in room 2. This will be 9 to 15 in room 2. Now all the meetings are scheduled. All the meetings we have are scheduled, and we can see there are only 2 rooms required for scheduling all the meetings. So here this explanation is we have done is by visualizing the input and the starting and ending time. So let's see how will we solve it by coding. Again we have input, uh, we have input 5 meetings. First of all, sort them. So we will sort it according to start time. So here this will be short like this. This is 1 3, then 2 6, then 7 8, then 8 10, then 9 15. Now for the first meeting, we need to assign a room. Room 1, this will be from 1 to 3. This is assigned for room 1. Now we will check for the second room. So for checking the second room, we need to check the ending time of the room. We have only one room, so ending time of this is 3. Having the ending time is 3 and our new meeting start from 2. So this means we need another room. So how will we get the ending time of the rooms we have? Let's say there are more rooms. One is ending from uh from 12 to 1. This is room 2. Let's say there is uh, let's take 12 to 1 instead of 12 to 1. Let's say there is a room from 1 to 2. So here, if it will check only for room 1, it will create another room for itself, because 1 to 3 is going in room 1. So we need to check, it will not check for the second room. We need to save all the rooms ending time, so we can check which meeting is ending first according to the ending time of the rooms. Here, if we see in room 2, the ending time is 2. So here 2 to 6 can be scheduled in room 2. So if it's scheduled in room 2, there will be no need to make another room. So we need to save ending times of the meetings of each room. So for saving that, I am going to use priority queue of min heap. Why priority queue? Priority queue min heap type. So in this priority queue, if we put this 3, the ending time of first meet. So this is a min heap type. At the top, the 3 will be here in the top. Now it will check. It will check at the top. There is 3. If the start time is less than the peak of the priority queue, that is the top of the priority queue, this means we need another room. We need another room for this meet. Here the ending time is 3 and the next starting time is 2. Next meet starting time is 2. So this means for this meet we need another room. So we will create a room 2 from 2 to 6. Now we have two rooms. One is ending at 3, another one is ending at 6. So we need to save the ending time of second room also. So we will push this 6 in our priority queue. Now why I am taking min heap type? Because min heap type will pop the smallest value first, and we need the room in which the meeting is ending first, so that we can assign the next meeting, we can schedule the next meeting in that room. So that's why we are using min heap. Now for the second the next meet, that is 7 to 8, it will check at the top. Here the top is 3. Here the start time is 7 and the ending time of room 1, that is 3. So this 7 to 8 meet can be scheduled in room 1, because the meet from 1 to 3 is already done. It is done till 3, and our next meet will be start from 7 to 8. So this means this 7 to 8 will be scheduled in room 1, scheduled in room 1. And in the priority queue, we will push this ending time, that is 8. but we need to pop the previous meeting that is in the room 1, and at the room 1 the previous meeting was 2 to 1 to 1 to 3, and here 3 is at the peak. So we need to pop this. It will be popped. Now we have two rooms. We have two rooms. One is ending at 8, another one is ending at 6. And in the priority queue, we can see there are only two elements, two rooms and two elements. So by the priority queue size, we can check the number of rooms we have assigned for the meetings. Now it will go for the next meet, that is from 8 to 10. This time at the peak there will be 6. Again it will check with starting time of next meet and ending time. Here 6 is ending and 8 is starting. This means this 8 to 10 can be scheduled in room 2. So this will be scheduled in room 2 from 8 to 10, and this ending time of 8 to 10 will be pushed in priority queue. And we are using the same room of this meet which was ending at 6. So we need to pop it. So we will pop it from the priority queue. Now at the peak, it will be at the peak. Now the next meet is 9 to 15. 9 to 15, again it will check for the starting time and the peak at the top of the priority queue. Here the starting time is greater and the ending time of the priority queue is 8. This means 9 to 15 can be scheduled in room 1. So we will push again. 9 to 15 is in room 1, and we will push the ending time of room 1. We need to update the ending time of room 1, and at the previous the ending time was 8, so we need to pop this 8. It will be popped. It is in the top of the priority queue. And now all the meetings are done. And at the end we have in the priority queue there are two meetings. One is ending at 15, another one is ending at 10. So this means there are only two rooms required for the meetings, for these 5 meetings to be done. So the answer will be the size of the priority queue. Now the steps are first we need to sort the array according to the start time. Second is we need a priority queue of min heap type. And third is the conditions when we need to create a new room, or we need to we can use the existing room. So there will be the condition of if else. If pq dot top is greater than the start time, is the next meeting start time. This means we need another room, so we will push the end time of next meeting. Else we need to pop pq dot pop the previous meet ending time in the room, and we will push the new meets ending time in the priority queue. So these are the conditions. Now let's code this. So here first we need to sort the array dot begin comma array dot end according to the start time, which is at here. This will be bool short call const of vector int for sorting a comma const vector int b. and we need to compare A0 is less than B0. This will sort in ascending order according to the start time. We are giving here A0 and B0. Why? Because our start time is at the 0th index of the array. Here it is I0, that is 0 0 0 1 1 0 2 0 3 0 4 0. So this means all the starting time is at the 0th column. Now this will sort the array according to the start time. Now we need a priority queue. Priority queue of min heap type. So we need to make it min heap vector int greater int. This will make it in min heap, because in CPP priority queue is of max heap type. The default priority queue is of max heap type, so we need to make it in min heap. Now we just need to iterate from 0 till array dot size I plus plus. Now the conditions: if priority queue size is 0, this means there is no meeting room assigned. So we will push in priority queue the first meets ending time, that is at array I ending time is at 1. Else this means there are rooms available. So here we will check if priority queue dot top is greater than array at I at start time. Start time will be at 0th index, I at 0. If this is true, this means we need to push another value, that is array at I of 1. This means we need another room. There was a condition when meeting start from 1 to 3, another one is start from 2 to 6. So at the top there will be 3. Here 3 is greater than the start next meet start, that is 2. So this means we need one room, again one new room. So we are saving the end time of this meet 2 to 6 in this condition. Now else if this is false, this means we have room, so we need to pop the meet, we need to pop the last meet from that room, and we need to push the new meets ending time. And at the end we just need to return the priority queue dot size. So this is the simple code. Let's run this. So let's try to submit this. So all the test cases are passed. Here I have sorted the array according to start time of the meet. Here this is priority queue of min heap type. This is the condition when there is no room. So this is for first row. This is for the first room assigned to a meeting. Here else there are rooms, so it will check for new room. This means we need another room if the top is greater than the next meet start time, and this is for the existing room. So these are the conditions, and these are the this is the approach to solve this question. So hope you understand the video and the explanation. We'll see you in the next video. Thank you.